Humbug Whistle? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
All right, welcome back. Today we've got an exciting problem. I'm going to draw first my coordinate plane right here. So we've got a very active frog. I'll use green since it's a frog to show the vectors where he's going to be jumping here. So first he jumps along the x-axis in the west direction, so the negative x direction, jumps a distance of 27.0 centimeters. Then he kind of jumps this way a little bit, forming an angle of 35 degrees and a distance of 23 centimeters. Then here's east-west line right here. He jumps at an angle of 55 degrees south of east, a magnitude of 28 centimeters. I'll draw one or more of those so that you can jump upwards. A distance of 35 centimeters, forming an angle of 63 degrees. So we want to find this resultant vector right here. Please note that this drawing is not really drawn to scale at all. So looking at it isn't going to really help us. It'll give us a general idea of what we're looking for, I guess. So first we're going to solve for all the x components. And for this problem, it's convenient if I define a positive direction and a negative direction. So my positive y direction will be facing this way. Positive x direction will be facing this way. And I could have made either or both of these arrows facing in the opposite direction. It doesn't really matter. It will give me the same result in the end as long as I perform all the calculations correctly. But it is convenient, and hopefully you'll see why as we start going through this problem. So let's solve for the x components first. So his first leap number 1, we can find that using, well, it's just 27 centimeters in the negative x direction. So look at that. You already get to see why I'm using the negative sign. So if he's jumping in a direction opposite of the, if the vector representing his leap is in the opposite direction of where I define positive, it's going to be negative, right? All right, his second leap, also in the negative direction. So keep that in mind. I'll just write it out here, I guess. So negative, and then he jumps magnitude of 23 centimeters. Take the cosine of 35 degrees, giving us 18.8 centimeters. The third jump, he's jumping in the positive direction this time. Here's his third jump right here. Second, first. Oh, looks like I ran out of space at the top of the board there. And his fourth jump is over here, right? So his third jump, magnitude of 28 centimeters, forming an angle of 55 degrees. That is going to give us 16.1 centimeters. The fourth and final leap is going to have a magnitude of 35 centimeters, forming an angle of 63 degrees, which gives us 15.9 centimeters. All right, so we're going to add up all these components right here. You'll see we have the, oops, I forgot to write. There we go. These two negative components, these two positive components, and that'll all come out to be negative 13.8 centimeters. So that is the component of the blue vector, the resultant vector right here. All right. That is the x component of that vector. Let's do the y components for these vectors. All right, same idea right here. So the first vector right here has 0 because it doesn't go up or down. The second one is 23 times the sine of 35 degrees. And really, this should be a negative because it is going down, right? The opposite in the direction that we defined as negative. That is equal to negative 13.2 centimeters. Jump number 3, he jumps again in the negative direction. Scale up by 28 times the sine of 55. That is going to give us 22.9. In the fourth and final jump, he's jumping in the positive direction. So that is 35 sine 63, which is equal to 31.2 centimeters. All right, adding those all together, we find that the y component, should have written the other one in blue too. Oh well, we'll just trace over it. Oh, that turned ugly. All right, well that's still a 13.8. You can just use your imagination now. We want to find the magnitude of vector r. So that is going to be square root of negative 13.8. Really, it doesn't matter if I write the minus sign there because once you square it, it goes away. I'll write it there anyways, just so you know where it goes, where it comes from. The magnitude of the vector r is going to be about 14.6 centimeters. The angle is going to be arctangent of, again, drawing this like that. Oops, actually I should have drawn it over here. We're going to draw a triangle like this. Here's the angle we're looking for. So here's the side opposite, the side adjacent. The adjacent side is the x components, 13.8. The y component, excuse me, I said that wrong. I did that wrong right there. The opposite side is going to be the y component. Oops. There we go. Now it's blue. 12.9 over 13.8, giving us about 19.5 degrees south of due west. All right. So there are your two answers. Hope that was helpful. Good luck on the rest of your homework.